Hey everyone, and welcome back to Coffeesodes. I'm Josh, your host for episode 22.
And I'm Kelly.
Excited to join us for another deep dive.
Oh, absolutely.
So today, grab your coffee and get ready to learn something new with Coffeesodes, where we take research you send our way and break down the most interesting parts. We're talking about academic papers, articles, even your own notes. You can check the episode description for more details about the research we'll be covering today.
Sounds good.
So today we're tackling the fascinating world of wildlife surveys. But hold on to your binoculars, because we're not talking about your typical boots-on-the-ground observation. Now we're going high-tech this time. This deep dive explores how scientists are using remote sensing technology, basically satellites and drones, to study and count animals from the sky.
Counting critters from the clouds.
You're telling me.
That sounds straight out of a sci-fi movie.
This field is evolving at an incredible pace. Imagine this. With drones, researchers can spot individual animals as small as seagulls. And get this, satellites can even be used to count emperor penguins all the way from space.
Penguins from space. Okay, you've officially hooked me. I need to see this to believe it.
Well, luckily, the research you sent over includes some incredible visuals. Figure 1 showcases the variety of animals detectable by these methods. We're talking everything from massive elephants to those tiny penguins, even koalas hidden in dense foliage.
Okay, I'm looking at figure 1 now, and I see what you mean. The level of detail is pretty amazing.
Yeah.
So let's break down the two main approaches here.
Okay.
Satellites and drones.
Sounds good.
What are the key differences in how they're used for wildlife surveys?
So satellites are like the masters of wide-scale observation.
Right.
They cover vast areas like entire continents or oceans and passively collect data, meaning they're not directly interacting with the environment or disturbing the animals.
Right.
Think of them as the ultimate big-picture observers.
That makes sense for something like tracking migratory patterns or monitoring large populations over time. But what about getting detailed information about specific animals or smaller areas? Is that where drones come in?
Exactly. Drones excel at providing those close-up, high-resolution images.
Yeah.
They're also super flexible. Researchers can deploy them quickly in response to specific events or weather conditions.
Right.
Plus, they're more cost-effective than satellites for smaller-scale studies.
So it seems like the choice between satellites and drones depends on the research question and the scale of the study. But either way, isn't it incredibly challenging to actually spot animals from above, especially with things like camouflage and dense vegetation?
You're absolutely right. It's not as simple as just pointing a camera at the ground and counting dots.
Right.
One of the biggest challenges is contrast. Animals need to stand out against their background.
Oh.
Imagine trying to find a polar bear against a snowy backdrop.
Oh.
Talk about blending in.
And I imagine size plays a role too, right?
Yeah.
Especially with satellite imagery, a tiny insect wouldn't even register as a pixel.
You nailed it. Animals need to be large enough to be picked up by the sensors, particularly with lower resolution satellite imagery.
Right.
And you're also spot on about dense vegetation. Forests and jungles can be a real obstacle, obscuring animals from view.
Right.
Open habitats are definitely the sweet spot for these types of surveys.
So what happens when researchers can't directly see the animals they're trying to count? Do they just give up?
Not at all. That's where things get even more interesting. Scientists have come up with some incredibly creative solutions using what's called indirect population assessment.
Indirect assessment? I'm intrigued.
No.
What does that involve?
It's like being a wildlife detective.
Okay.
Instead of counting the animals themselves, researchers look for clues or proxies that can help them estimate population size.
Give me an example.
Okay.
I'm a visual learner and I need a picture in my mind.
Okay, picture this. Researchers studying penguin populations in Antarctica can't always see the birds themselves,
Right.
especially with lower resolution satellite images,
Okay.
but they can see something else.
Okay.
Guano stains.
Wait, penguin poop. You're telling me they're using penguin poop to estimate population size?
You got it. And here's where it gets even cooler. Guano has a unique spectral signature that allows researchers to pinpoint entire penguin colonies from space.
Oh, wow.
It's like a fingerprint that sets it apart from other materials.
That is seriously ingenious.
Yeah.
So they're not just taking pretty pictures, they're analyzing the light reflected by different materials to find hidden clues about animal presence.
Exactly.
Okay.
It's all about how different materials reflect light.
Right.
Everything has a unique way of interacting with light, like a fingerprint or a barcode.
Uh-huh.
And by analyzing this reflected light, researchers can differentiate animals from their surroundings.
Okay, that makes sense.
Yeah.
They've got their high-tech eyes in the sky. They're analyzing light patterns.
Uh-huh.
And they've managed to count these critters, or at least estimate their numbers.
Right.
What happens next?
Well, it's not as simple as just taking the raw count and calling it a day. It's important to remember that these aerial surveys provide snapshots in time.
So how do they go from those snapshots to understanding the bigger picture of how these animal populations are doing?
That's where correction factors come into play.
Okay.
Researchers need to account for things like breeding behavior, the presence of non-breeding individuals, and even the possibility of double counting if only one partner in a breeding pair is visible.
It's like factoring in all the variables that might affect the accuracy of those initial counts.
Right.
Sounds like a pretty complex process.
It definitely is, and it's constantly evolving as technology advances. Speaking of which, we've come a long way from simply having people manually count animals in those images.
You mean we don't need an army of interns painstakingly scrutinizing satellite photos anymore?
Well, sometimes we do.
Okay.
Manual counting is still a valuable method,
Right.
especially for smaller surveys or for validating the results of automated approaches.
Yeah.
But things are definitely moving towards automation.
Tell me more. How are scientists automating this process? What kind of tech are we talking about here?
There are a few different approaches.
Okay.
One that's really taken off is the use of citizen science platforms, like Zooniverse.
I've heard of Zooniverse. Isn't that where anyone can help classify galaxies or identify animals in camera trap photos?
That's the one. These platforms allow researchers to tap into the power of crowdsourcing.
Wow.
People from all over the world can contribute to wildlife surveys by reviewing images and identifying animals. It's like a global team of wildlife detectives.
That's amazing.
Yeah.
But what about true automation, like with artificial intelligence? Is AI playing a role in this too?
Absolutely. That's where things get really futuristic.
Yeah.
AI is revolutionizing wildlife counting, offering speed consistency and the ability to process massive amounts of data much faster than any human could.
Okay, I'm officially geeking out here.
Yeah.
But AI isn't perfect, right? What are some of the challenges researchers face when using it for wildlife surveys?
One of the biggest hurdles is the need for massive amounts of training data.
Right.
AI algorithms need to be taught what to look for, and that requires feeding them tons of labeled images. Essentially, they need to learn how to see like a wildlife expert.
So even with AI, we still need that human element to guide the process and ensure accuracy.
Right.
It's a fascinating partnership between human expertise and cutting-edge technology.
It is. And even with all that training, AI can still make mistakes, especially when it comes to distinguishing animals from their background in complex environments.
Yeah.
So it's a work in progress, but a very exciting one. What does the future hold for counting critters from the clouds? What's on the horizon for this field?
Oh, I'm excited to hear about this.
The future is incredibly bright.
Okay.
New higher resolution satellites are being launched all the time,
Yeah.
providing better coverage and more timely data.
Right.
And get this, there's even talk of super high resolution imagery, less than 25 centimeters per pixel, becoming available for environmental monitoring.
That's mind-blowing.
Yeah.
We're able to see things in incredible detail. And I bet AI will continue to play an even bigger role.
Absolutely.
Imagine using this technology to monitor endangered species, track poaching activity, or even assess the impact of climate change on animal populations. The possibilities are endless.
Couldn't have said it better myself. Now, before we move on to part 2, I have a question for you.
Okay.
If you had access to this incredible technology, what animal would you want to count?
That's a tough one. But for me, I'd have to say sea turtles. I've always been fascinated by their epic migrations across vast oceans. Imagine being able to follow their journeys from space and unravel the secrets of their ancient navigation system.
That's a fantastic choice. I can already picture the stunning satellite images. But for now, we'll have to leave those dreams for later.
Okay.
Join us in part 2 as we explore some of the applications of this technology and delve deeper into the exciting world of AI-powered wildlife counting.
Sounds good.
You won't want to miss it. And be sure to check out the show notes for links to all the research we've discussed today. Welcome back to Coffeesodes. We're diving even deeper into the world of remote sensing for wildlife surveys. It's mind-blowing to think about all the possibilities this technology opens up for understanding and protecting animals. What are some of the specific ways researchers are using AI to analyze wildlife data?
One area that's particularly promising is the development of deep learning algorithms. These algorithms are inspired by the structure and function of the human brain.
Oh, wow.
Essentially, they use artificial neural networks, complex systems of interconnected nodes to process information and learn from data.
Okay, that sounds pretty high-tech, but how does that translate to actually studying animals?
Well, think of deep learning as a way to teach a computer to see patterns and make predictions based on those patterns.
Right.
For example, we can train these algorithms to recognize individual animals based on their unique markings, or predict an animal's future movements based on its past behavior.
So we're talking about AI that can actually learn and adapt over time.
And the more data we feed these algorithms, the better they get at making accurate predictions. One really exciting application of this is in the development of AI-powered camera traps.
Now, those are something I understand. Camera traps are those cameras that automatically snap photos of animals in the wild, right?
That's right. But now imagine those camera traps equipped with AI that can instantly identify the species in the photo,
Right.
even estimate the animal's age or sex.
Wow.
It's like having a personal assistant for every camera trap out there.
That would be a game changer. No more sifting through mountains of photos. Researchers could focus on analyzing the data and developing conservation strategies.
Exactly. One area that's particularly exciting is the integration of multiple data sources.
Oh.
Think about combining satellite imagery with drone footage, acoustic recordings, even data from animal tracking collars.
So we could create a much richer and more nuanced understanding of animal behavior and ecosystem dynamics by layering all this information together.
It's like having a 3D view of the natural world.
Exactly.
And with AI, we can analyze these complex data sets
Right.
and uncover hidden patterns and connections that we might never have seen before.
Okay, I'm officially blown away by the potential of this technology.
Yeah.
But I also keep thinking back to the ethical considerations we touched on earlier. It seems like there's a lot of responsibility that comes with wielding such powerful tools.
It is, especially when using drones.
Yeah.
We need to be mindful of the impact our presence might have on the animals and their environment.
We need to make sure we're not stressing the animals or disrupting their natural behaviors.
Right.
But what about the data itself? What are some of the ethical challenges related to collecting and using data about wildlife?
That's a great point.
Yeah.
Data privacy and security are crucial considerations,
Oh, yeah.
particularly when dealing with sensitive information about endangered species or animals that might be targeted by poachers.
Right. That's a good point. It sounds like there's a lot to consider, but ultimately comes down to using this technology responsibly and ethically.
Exactly. Technology is a tool. It's up to us, the researchers, the wider scientific community and society as a whole, to ensure that it's used for the benefit of both humanity and the natural world.
Well said. Now, before we wrap up part 2 of this deep dive, I have a question for our listeners.
Sounds good.
Imagine you're a wildlife researcher with access to all the latest remote sensing technology and AI tools. What groundbreaking research project would you want to tackle? Welcome back to Coffeesodes for the final part of our deep dive into counting critters from the clouds. Now I'm ready to talk about solutions.
Okay.
How could all of this tech actually be used to make a real difference for conservation efforts on the ground? Give me some specifics. How can remote sensing and AI actually be used to protect animals in the real world?
Well, for starters, think about monitoring endangered species. We can use satellites and drones to track their movements, assess their habitat, and even identify potential threats like poaching or habitat loss.
So it's like having a global surveillance system for the animals that need it most.
Right.
We can keep a watchful eye on them, even in the most remote and challenging environments.
Exactly. And it's not just about monitoring. We can use this data to inform conservation strategies, prioritize resources, and even predict how animals might respond to environmental changes.
That's crucial, especially in the face of climate change.
Another exciting area is anti-poaching efforts.
Okay.
Imagine using drones equipped with thermal imaging to patrol vast wildlife reserves, detecting poachers in the act.
Wow, that's some serious crime-fighting technology.
Oh.
It sounds like something straight out of a wildlife spy movie.
It might sound futuristic, but it's already happening in some parts of the world.
This technology allows us to move beyond isolated studies and take a more holistic approach to conservation.
Right?
Okay.
Uh-huh.
But what about the challenges? What are some of the biggest hurdles we face in using this technology for conservation?
One of the biggest challenges is access to resources.
Mm.
High-resolution satellite imagery can be expensive, and not all countries have the same level of technological infrastructure.
So it's a matter of making this technology more accessible and affordable,
Right.
especially for developing countries where conservation is most critical.
Absolutely.
Yeah.
Another challenge is data management.
Yeah.
We're talking about massive amounts of data,
Right.
and we need to develop efficient ways to store, process, and analyze it all.
I can imagine that's a data scientist's dream or nightmare.
It is a lot of data,
Yeah.
but it sounds like an exciting challenge.
This has been an amazing deep dive.
It has.
I've learned so much about how technology is revolutionizing the way we understand and protect wildlife. And I have to say, I'm feeling pretty optimistic about the future.
Me too.
Now, before we sign off, I want to remind our listeners to check out the show notes for links to all the fascinating research we've discussed. And be sure to subscribe to Coffeesodes for more deep dives into the world of science and technology. Thanks for joining us. Until next time, keep exploring and stay curious.